Good morning and good afternoon to our audience. Let's not wait any longer. If anybody joins later, they can just start watching from there. And remember, we will share the video online on YouTube and Youku afterwards. So the Chinese and the Dutch audience can both see the video later. We'll first start with our video session, and then afterwards we'll go to the Q&A session. The presentation session will be a pre-recorded video, and the Q&A session will be live. Good afternoon to our Chinese audience, and good morning to our Dutch audience. Welcome to the second episode of our hydrogen webinar series with a total of 5 webinar episodes over the course of these 5 weeks. My name is Fons. I'm the host of today's session. I'm working for the Netherlands Innovation Network in China, Guangzhou. And this webinar series is brought to you by the Netherlands Innovation Network in China, the Consulate General of the Netherlands in Guangzhou, and the UNDP. For this second webinar, we have an interesting program again with various speakers focusing on the production of green hydrogen. We start with an opening speech of Mr. Zhang Weidong, who is the Program Director of Energy and Environment Team of the UNDP. Then we move on to an introduction on Dutch green hydrogen production projects by Jörg Gigler, who is the Managing Director at TKI New Gas, Top Sector Energy. After Jörg, we will switch to Hui Zhao, who will talk about green hydrogen production in China and practices in Zhangjiakou. Following Hui Zhao, we'll focus on 2 more in-depth projects from Dutch research institutes and a company who are both already very active in the field of green hydrogen production, namely Lennart van der Burg, who is the Business Development Manager of Green Hydrogen within TNO, and finally we continue and finish with Wilco van Kampen, who is the CEO of Syntec, who will give an introduction of their smart alkaline systems. Same as last week, there's the possibility to ask questions via the chat. There's a live connection with different speakers. And while the webinar is progressing, they can already respond to messages in the chat. But at the end of the presentation session, there will also be a live Q&A session with a simultaneous translator. We really recommend everybody to already type your questions in the Q&A during the webinar, so our translator has the opportunity to provide us with a translation before the start of the Q&A session. If you wait with your questions till the end of the presentation session, chances are that we're not able to address your inquiries during the Q&A session. Thank you. We are now transferring to Mr. Zhang Weidong, Program Director, Energy and Environment Team of the UNDP, with his opening speech.
谢谢方子的介绍。各位嘉宾、女士们、先生们，大家下午好！欢迎各位来到由荷兰王国驻广州总领馆、荷兰科技与创新官员办公室、联合国开发计划署驻华代表处共同举办的氢能线上系列研讨会。首先，我要指出一个显而易见的事实，那就是氢能和燃料电池行业是解决我们当下面临的严峻挑战的重要手段之一，而这个挑战就是气候变化。2015年，联合国193个成员国在联合国可持续发展峰会上正式通过了17个可持续发展目标，其中目标7是经济适用的清洁能源，目标13是气候行动。2016年，178个缔约方签署了巴黎气候协定，其长期的目标呢是将全球平均气温较前工业时期上升幅度控制在2摄氏度以内，并努力将温度上升幅度控制在1.5摄氏度以内。氢能与实现这2个可持续发展目标，以及巴黎协定 限制温度增幅的这样的目标呢，有着直接的联系。如果以交通和能源领域为主的经济活动的碳强度不能大幅度降低，我们就无法实现这样的目标。但我们知道，只有绿色低碳的执行过程，才能从根本意义上助力实现脱碳减排的目标。荷兰和中国都有着丰富的可再生能源禀赋，同时呢，又在国际氢能方面各自发展了推动的作用。因此，为促进两国的政府、企业和学术界进行深度交流，我们从6月10日起呢，每周三下午4点呢，为大家推出氢能线上系列研讨会。本周的线上研讨会的主题是知氢绿色氢能。我们也会在未来呢，继续推出氢能在交通和工业领域的应用，从科研和技术视角来看氢能，以及氢能在中国的发展机遇与挑战的专题研讨，欢迎大家持续关注。在此，我谨代表联合国开发计划署驻华代表处，预祝今天以及未来的研讨会能够进一步促进中荷两国的合作取得丰硕的成果。谢谢大家。
Thank you, Mr. Zhang Weidong, for your opening speech. Then we will now continue straight to Jörg Gigler, Managing Director at TKI New Gas, Top Sector Energy, with his introduction on Dutch green hydrogen production projects.
Hello, ladies and gentlemen. It's a great pleasure for me to present this overview of hydrogen policy, innovation, and projects in the Netherlands to you. My name is Jörg Gigler, and I'm working with the Top Sector Energy in the Netherlands, and as director, I'm responsible for, amongst others, hydrogen. I will be talking about 3 things. I will elaborate on the strategy for hydrogen of the Dutch government. I will talk about the innovation strategy for hydrogen, and I will give you some examples of hydrogen projects in the Netherlands. First of all, there are a couple of important milestones for hydrogen in the Netherlands. I think the first one is the climate agreement that was reached in 2019, in which it was agreed that in 2030 we should reduce CO2 emissions by 49%, and in 2050 we should be carbon neutral. In January, we released an innovation roadmap for hydrogen, and I will be talking about that. And in March 2020, the Dutch government released their strategy on hydrogen. So together, this in the Netherlands and also some European announcement on hydrogen, for example, the European Green Deal and the Economic Recovery Plan in conjunction with COVID-19, has made hydrogen the top of the agenda regarding the energy transition. So why does the Netherlands have so much interest in hydrogen? I think a very important aspect is that we have an excellent infrastructure as far as harbors, energy grids, road and rail is concerned, and we are very well connected to Europe, as you can see in the small picture, and the red dot is the Netherlands. We also have 5 industry clusters where there's a lot of energy intensive industry concentrated, having a very high hydrogen demand. We are located near the North Sea, which is very shallow, at its deepest about 40 meters, which is an excellent production potential for offshore wind, producing a lot of renewable electricity, which is suitable for producing green hydrogen. And we have an excellent knowledge infrastructure as far as universities, research institutes, and consultants is concerned. There are much more reasons to mention, but I think this is the main part why we are so interested in hydrogen. So I will now skip with you to the government strategy that was released in March. It's a government strategy on hydrogen, and I first will explain to you the philosophy behind this government strategy. the government realizes that we need hydrogen for full decarbonization. It does not mean that hydrogen is the only solution, but it is very well part of our energy transition towards 2050. What's also being recognized is the systemic role that hydrogen can play. In some countries, it's also called sector coupling, that it couples different sectors to each other and thus provides the flexibility that we need in an energy system that is dominated by solar and wind. It also recognized a government strategy that green and blue hydrogen is necessary. So green hydrogen made from renewable electricity, blue hydrogen made from natural gas, where we capture and store the CO2. It also recognizes that there are many, many opportunities for companies and our innovation community associated with hydrogen. And the last but not least, it says that to make this a success, we really need international collaboration. So the policy agenda that comes with the government strategy on hydrogen consists of 4 parts. The first part has to do with the basic task of the government, which is legislation and regulation, looking at infrastructure, looking at the role of our network operation, safety, certification, just some examples that have to do with this point. The second one is more of a technical nature, which is cost reduction and scaling up of green hydrogen. For example, cost reduction of electrolyzers and of fuel cells. And the government is looking here at support schemes, is looking at the production of electricity, if it should be used pure or in blending with natural gas, etc. The third one is that the government mentions in their policy agenda the sustainability of end use. It does not make choices, and it would be too early for that yet, but says that hydrogen or other products associated with hydrogen are necessary in industry, mobility, the built environment, the electricity sector, and agriculture. So there are many markets that can be served with hydrogen. And the last one is that the government also sees the necessity of a supporting and flanking policy. It means that we need an international strategy, but we also need to focus on regions that are important to make this hydrogen dream come to reality, and research and innovation is necessary to be supported by subsidies. And the government promised in their government strategy on hydrogen that a hydrogen program should be established that puts all these things together and addresses them together with all stakeholders in the Netherlands. The next step is that I will be talking about the hydrogen innovation roadmap. That was released in January, and I'm one of the main authors together with 3 colleagues. And first of all, I will give you the background. In 2018, we published the outlines of a hydrogen roadmap. And at the end of my presentation, I will give you some links so you can download these documents. It was meant to be an informative document on hydrogen, sketching the innovation needs. In January 2020, we actually published the innovation roadmap for hydrogen called Hydrogen for the Energy Transition. And what we've done in this innovation roadmap is, in about 1 year, we had many discussions with stakeholders throughout the countries. So we gave them the opportunity to provide input, to have discussions with them, and to come up with a roadmap that has a lot of support among the innovation community in the Netherlands. Okay, so what exactly is written in that innovation roadmap? The strategy that we suppose consists of 5 different topics. The first one is that we have to look at policy making. We need policy, so we need to get from vision to policy. And with the government strategy on hydrogen, that's there. It's not complete yet, but we have a start. The second one is that we need demonstration projects so that we can really show these practical projects in all different applications to the public. And I will address this later in my presentation. The third one is that we need to create the required conditions so that hydrogen can grow and can scale up, which means the policy, I addressed it already, legislation, infrastructure, safety, we need standards, gas quality issues, etc. The fourth issue that I would like to address is that we said we also need R&D for the long term. So not only demonstration projects with short-term R&D, but also long-term R&D, for example, focused at finding better materials to produce electrolyzers, bringing the cost down as far as the material is concerned, or increase the efficiency, or even the maintenance intervals. And the fifth one is that we said we also need supporting activities for implementation, which means the so-called human capital agenda, education, training, the workforce that we need to do this, communication and information to the public, and public acceptance. Just some examples of issues that are necessary. So 5 points that are part of the innovation roadmap for hydrogen. The last thing I would like to do is to look with you at hydrogen projects. We released an overview recently, and I will give you a link at the end of my presentation, to hydrogen projects in the Netherlands. And I only pick out 3 of them. The first one is that in the northern Netherlands, in an industry cluster, there are plans of realizing a 20 megawatt electrolyzer that will produce hydrogen, about 3,000 tons per year, to be used for the production of biomethanol, and a little bit of it will go into mobility. So that's the first one, electrolyzer producing green hydrogen for industry. The second project I would like to explain to you is the Heaven project. The Northern Netherlands has actually on a European scale been selected to be the first hydrogen valley in Europe and set an example of how hydrogen could be developed. There are about at least 50 partners. Total project costs are 90 million. And the interesting thing about this project is that it is an integrated project. So it's about industry, it's about storage, it's about infrastructure, it's about mobility, the built environment, and linking them all together and see how in a valley, in a certain region, this concept of hydrogen can be developed. The third project I would like to present to you is the so-called High Stock project. This is a project also in the Northern Netherlands where a 1 megawatt electrolyzer is coupled to a large scale energy storage, which is actually a gas storage in a salt cavern. It has started with a 1 megawatt electrolyzer that is running already, and it is foreseen that this will be scaled up so that in the future a whole salt cavern can be used for long-term storage of hydrogen, so that we have a buffer between production and end use of hydrogen. So this project is already realized, and it will be enlarged in the next years. So what I would like to say to you in conclusion is, first of all, in the Netherlands, we have a government strategy in place that is also supported by Europe. So that is very good news. We also have an innovation strategy in place, and that has full support of Europe. So that's also really a condition that needs to be met to be successful. And we see that many projects are being executed or are ready for demonstration and implementation, which means that we can make the necessary step from paper to projects and demonstrate the full potential of hydrogen. And I would also like to note that we have only just started, and that an international effort has to be made, a joint international effort. So collaboration is key so that we can realize that crucial role of hydrogen in the energy transition, which means that we need you as well. We need to collaborate to make hydrogen a success, because the challenge is enormous. So I would like to thank you for your attention. My name and my address is given here. So if you have any questions, please contact me. And I provided a list with 4 downloads that you can get from our website. I thank you very much for viewing this presentation. and I look forward to meeting you in person maybe next time. Thank you very much.
Thank you, Jörg Giggler. It's very interesting to see how many different green hydrogen production projects are already active in the Netherlands. Thanks again. A quick message to the audience. Please remember that all the speakers are present live and are already able to answer any questions via the chat. Then, we now move on to the next speaker, which is Hui Zhao, who will talk about green hydrogen production in China, in Zhangjiakou specifically. Hui Zhao, please go ahead.
今天就给大家讲解一下中国的可再生制氢情况，以及我们在张家口做水氢加氢站的这个工程实践的情况。这是中国氢的主要这个工程方法。在这个中国和国际上的所有的制氢方法里，基本上都是一样的，都是有各种什么化石能源、工业副产氢制氢，还有这个高温分解，这个电锐制氢，这个方法都是一样的，只不过就是这种方法的这个比例是中国和国际上是有区别的，因为中国是一个煤炭非常多的这个国家，所以中国煤制氢是在绝对的很多的，是48%，在国外呢是48%是天然气的，这是跟中国的国情是相关的。但是电解水基本上都是占4%，这个比例都完全是一样的。在中国的这个每年的氢气产量差不多有将近2000万吨，这个占全球氢气产量差不多30%左右，但是大部分全都是工业用氢。在可再生能源制氢方面呢，国际和中国都是对它是非常重视的，包括美国、欧盟、印度、巴西，全把这个可再生能源发展当成一个重要的能源发展的方向。在中国，可再生能源发电占这个比例也是逐年增多。这个是从这个比例上能够看出来，火电增长很低，然后太阳能发电是最高的，这是这个风力发电也是第二的。在中国可再生能源的发展过程中，存在了一些个问题，就是因为中国的可再生能源大部分集中在西北地区，这个地区的用电量，当地用电消耗比较少，输送电力呢，也有些困难，所以存在大量的气风、气水、气光现象，就是这些用可再生能源发的电，并没有从电网上输送出去。这是从图上可以看到，我们从这个气风、气光、气水的这个电，可以做了很多的这个用途，其中可以做电网发电，还有通过电解水，通过电解槽制氢，把氢作为储能使用，同时把氢气可以应用于氢能交通方面。在中国可再生能源气风的电量很大，可以保证这个几十万辆车的这个运营。现在这个车的这个数量主要是参考中国的这个商用车，因为商用车现在是中国的主流，它这个。我们现在说的气风、气光、气水，主要是集中在中国的西部，比如这个新疆、甘肃、内蒙啊，包括中国的这个四川还有云南这些地方，都有一些这个大量的这个气光、气水、气光现象。这个按照他们这个激光的气风电量的产量，可以把这些直接用于氢气制造储存，可以按照这个消纳是147亿千瓦时的气电。 从目前电解水制氢的这个工艺来说，我们现在看到有3种典型的这个制造氢气的这电解水方法。第一是碱性电解水的，第二是这个叫纯水电解槽，第三是固体氧化物电解槽。现在我们大规模应用呢，一般来说都是碱性电解槽，这是在中国最普遍、应用最多的这个。它现在已经应用到各个地方，然后它这个产氢量单台的容量已经达到了每台1000标方1小时的这个产量，它已经是大规模应用。从这个图片来说，我可以看到这是这个碱性电解槽的这个实际这个现场的安装，这是电解槽制氢框架提纯装置的这个图片。最后一个是这个纯水喷膜的电解装置。这个纯水电解槽装置目前在国外用的是比较多，在国内还没有大规模应用，主要是一些小的示范项目用。结合中国的情况呢，我们把电解水的这个制氢呢，这个电源分成2部分，一种呢是直接用风电直接现场制氢的，还有一种是把风电产的电量和这个电网同时协同一块儿给电解槽制氢做这个应用的。我们现在再看一看，我们在张家口利用风电、光伏发电电解水制氢的一个案例，给大家做一个解答一下。现在张家口是因为国家提倡是可再生能源这个应用基地嘛，这是国务院批复的。然后我们已经在张家口用了很多的这个案例在实施。主要在张家口，现在比如我们在建的这个叫望山制氢3氢站，是由张家口海布尔来运作实施建设的。现在1期是1小时2000标方的一个产能，就是每天氢气4吨的一个产量。然后2期要达到1小时1万标方的这个产能，就是差不多一年是2期达到7100吨这个产量，然后主要是满足张家口和北京地区奥运会2000多辆这个每天让它一直运行的这个需求。此外还有一些这个示范项目，在风电场直接这个利用风电制氢，比如在张家口这个有建投公司在张家口固远风电场直接建的制氢站，它是每小时800标方的一个示范项目。还有在张家口张北中节能公司呢，已经建成了利用科技部项目建成这个直接的风电制氢的这个项目。正在进行的是国家能源集团在上尹自己的神华风电场建成的这个上尹制氢站，现在项目正在实施，它是每小时1000标方的这么一个产能。此外，这个还有一些大的能源公司正计划在宁夏还有内蒙建设大规模的这个风电制氢，然后把这个氢气这个当地消纳，还有输送到周边地区，比如这个宁夏宝丰能源集团就在宁夏建成了一个每小时6000标方的一个电解水的基地，利用当地的这个光伏发电的这个电力。国家电投集团在内蒙古乌兰察布正在计划建设每小时3万标方的这么一个这个利用当地的风电光伏制氢的这么一个大的这个电解水基地，现在正在筹建中。在我们张家口海布尔做的这个1期项目中呢，已经建成了这个1期2000标方的这个电解水的产能，主要是就是通过入网的风电光伏的这个 电网的电进行便捷。我们计划就是现在正在安装调试，计划就是今年2020年的就是7、8月份就能够建成投产。二期呢，就明年的2021年要建成。主要是用于张家口的还有北京的公交车、物流车的燃料电池的运行的用氢需求。张家口到这个北京的这个距离呢，直线距离差不多是距离这个将近200公里啊。这个半径呢，对于这个长管拖车气体这个运输呢，正好是一个经济半径。经济半径就是比较合理的这个范围。超过这个距离呢，就是运费就增加了。因此，在张家口建立的风电场呢，其经济性还是可以有保障的。这是我们就是在张家口建成的望山制氢加氢站这一个鸟瞰图，这个产量呢就是一天4吨，还有同时复产那个液氧每天有30吨。它主要由这个电解槽的那个电解车间进行这个氢气生产，还有副产氧气的生产。氢气通过这压缩车间将这个气态氢气呢压缩到这个20兆帕和45兆帕2种。45兆帕的氢气用于充装那个我们附属的一个附属加氢站，这个加氢站全是张家口的这个大巴车和物流车使用。然后这个20兆帕的这个呢充装20兆帕的长管拖车，可以给张家口以及北京地区运送氢气，其中一小部分呢还充装一些工业钢瓶，作为工业上用途。这个整个一区占地呢差不多45亩地。今年这个就是7、8月份能够建成投产。是我们在制氢厂内部的一些设备情况。这个设备完全是采用中国国内的厂家制造的，包括这个比如10瓦的电解设备，它是用4台500标方的电解槽还有其中的附属的这个制氢框架、提纯装置。压缩车间呢也是国产的设备，是4台22兆帕的隔膜压缩机，还有2台45兆帕的隔膜压缩机。这个图片是制氢厂的一个高压储存的这个图片，左边这是将这个氢气通过压缩机储存在主罐里，然后加入这个那个燃料电池车辆，是给加氢站配套的。然后右边这图呢，就是由这个压缩机直接充装到这个长管拖车里头，一下呢可以充装7辆车。进行这个充装以后，把这个长管拖车运往这个张家口各地，包括北京的这个各个加氢站使用。我们再看一看电解水的成本。电解水的这个成本，主要的电费主要是在87%，这个是主要的电费是占绝大多数的。然后像就是说看出来，就是说如果电的这个成本呢，如果降低了，电解水的成本能够大幅度下降。这是从电解水的产量跟它的这个价格是成相关的关系呢。在它这个上方呢，这是每小时100标方的一个产能，下边呢是1小时1000方的一个产能。从上面可以看出，我产量越高，它这个氢气价格能够下降不少。右边的这个价格呢是就是水电、光伏包括风电上网的一个价格这是新能源国家上网的一个价格。我们从这个图上可以看到呢，是100标方的氢气这个价格呢，差不多是1公斤33到63块钱1公斤，这是在这个标准这个电价，就是中国工业标准电价的这个前提下，1000标方呢每小时电价呢是18到47块钱。这个电解水的价格是这个制氢里头成本里头是这个价格是高的，但是因为它正好纯度是 价格里头是这个所有制氢的方法里是最好的，因此呢，我们燃料电池呢，采用这个电解水制氢呢是也很普遍，是最普遍的。我们从这张图可以看到，如果在国内采用气光、气风和气水发电的价格，是1毛5的每度1毛5的时候呢，我们电解水的制氢的价格呢也就是每标方是1到1块5，就是相当于是每公斤呢是差不多是11到16块钱1公斤，这个价格是跟那个化石能源，比如煤制氢、天然气的这个上限是已经持平了，因此呢，就是利用气光、气风的这个价格，完全可以跟化石能源制氢的这个价格去争了已经。再说到我们张家口这个实力，因为我们采用了这个张家口的这个风电，而且是气风气光的这个上涨的电进行电解水制氢，因此我们的价格能够做到比较便宜。我们给张家口公交经济那个加注的价格是每公斤30元啊，这个价格跟那个他们公交车进行这个用汽柴油那个运行的价格已经是持平了啊，因此在张家口这个公交车他们还是非常愿意用这个氢燃料车辆去进行运行。我们还有看到以后这个其中一部分还可以用工业尾气制氢。工业尾气制氢呢，它呢一般来说必须得经过提纯，要把一些杂质必须给提出去，才让车辆才能用。因此，这个也是在中国也是一个重要的方向，就是工业尾气提纯制氢。这个价格因为它那个来源不一样，因此价格也不是完全一样。这个它的价格也差不多是工业这个尾气提纯是1公斤13到16块钱1公斤。好，今天我主要是介绍了一下这个国内的这个氢气电解水制氢的情况，然后还有一些我们在张家口做的一些实例啊，请大家谢谢大家观看啊。
Thank you, Huizhou, for this great insight on China's hydrogen production situation. We will now quickly move on to the next speaker, Leonard van der Burg, Business Development Manager, Green Hydrogen at TNO. Leonard will share with us the Dutch experiences in green hydrogen production.
Hello, welcome in this hydrogen webinar series. My name is Leonard van der Burg, working at TNO, the Applied Research Institute. And in the coming 20 minutes I will talk about hydrogen and especially on water electrolysis and the roadmaps towards 1 gigawatt water electrolysis in 2030 or even in 2025. So let me first start explaining something about TNO. TNO is an applied research organization and we work on technical innovation, social innovation. And the unit where I work, the energy transition, we have one main purpose: reaching the climate agreement and reducing our CO2 emissions faster, smarter, and create a higher social acceptance. And that's why we work with around 1,000 colleagues in the energy domain. Besides the energy transition units, TNO have more units. And we're talking about hydrogen. And an interesting thing is hydrogen is present near all units in the industry, in the traffic and transport unit. And also on the circularity part. I will talk about a bit more later on. About the hydrogen program within TNO. Hydrogen will play a key role in the whole energy transition. And in this slide I will explain what are the main drivers, the reason why we should work on hydrogen. First of all, hydrogen, especially electrolysis, is a way that we can integrate vast amount of renewable electricity from solar, wind more effectively in our energy grid. So that's a really important role of electrolysis. The second is the seasonal storage. I mean, we need to find an alternative of current fossil fuels, and hydrogen can play a key role in seasonal storage of our energy, let's say. And the third and fourth one is we need to have alternatives for maritime, aviation sectors where up to now there are not really an alternative for the fossil fuels, and hydrogen or even synthetic kerosene can play a great alternative. and also for high temperature heating. And these are the main drivers in Europe. If you, for example, look at China, their motivation for example, like air quality is really important to reduce the emission and to get a cleaner air. That's really an important driver. So what are we doing within TNO? Within TNO we have 6 programs. We're working on over 50 different projects on hydrogen, and we've got more than 40 years experience in this field. So looking at this slide, here you see the hydrogen supply chain, you can say. We're looking at hydrogen production, mainly green, but also low carbon hydrogen. We're looking at storage of hydrogen underground in the surface, in salt caverns or empty gas fields. After that, we're looking at the infrastructure. Can we reuse existing infrastructure in the Netherlands? Because the Netherlands is one of the countries with the most highest gas infrastructure to all the housing and industry. And part of the infrastructure we definitely can reuse. And the end, we're looking at the use of hydrogen in different applications, in the automotive, in the aviation. And really important is the system approach. We always need to look where is hydrogen the best solution compared to, for example, heat pumps, compared to direct electrification options. So hydrogen will play a key role, but we look at the different options available. Yeah, in this webinar, I specifically focus on the hydrogen production by electrolysis. So the other aspects, it's not included in this presentation. A bit about the history. As TNO, we already worked on 40 years on hydrogen. This is a paper from 45 years ago where we explained that hydrogen will get a major role in the energy transition. The difference between 45 years then and where we're standing now is then the driver was mainly on nuclear energy actually. And now the driver is, there are a couple of drivers. I mean, as I explained, carbon CO2 reduction, the climate driver. The cheap electricity prices going down all the time, and we need the storage solutions. So now there are more drivers why hydrogen will stay instead of 40 years ago or even 10 years ago. So the hydrogen economy will grow definitely. And here you find a report where TNO worked on, where you advised, make actually a roadmap for the Dutch government from what is needed to make clean, green hydrogen available the coming years. Now we'll start first worldwide, what's happening on electrolysis, and then we'll go down to Europe, Germany and the Netherlands. This picture shows what's now the current status of electrolysis worldwide. So the last 10 years, 100 megawatts of electrolysis is built, let's say, mainly in the field of for the use of mobility and in industry. So that's not really a lot. So actually, if you look at the 100 megawatts over, let's say, 230 projects, and if you look now, there are a lot of projects in the pipeline, and we'll discuss a bit later in this webinar on that. One project we're looking at the Netherlands is a dual project. That project alone is already 20 megawatts. So you see the project size and the amount of projects is increasing. But just looking from a different perspective, if we look from hydrogen, for example, compared to solar energy, the hydrogen, especially electrolysis, is like 10 or even 20 years behind where the solar is standing now. So we really need to grow the market and further develop the technology. If you see here, that's a projection up to 2030. If we want to reach 100 gigawatt scale in 2030 worldwide as a capacity. If you take the same graph and you put it about investment on the renewables for solar, wind and water power, you see that the investment on electrolysis is still minor, but it's actually really growing. But we are, we're just now in the front stage of the development on electrolysis. What are the main drivers for green hydrogen? This is a really important map where you see from what are potential leading countries where electrolysis can be competitive towards the alternatives. And the main drivers is, for example, wind and solar power. And they looked at from the amount of solar during the year, the amount of wind during the year. I also include the Netherlands and Germany here. And this is not an extensive list, just a number of countries are given. But if you look at the Netherlands and Germany, we're now building the largest wind park in the North Sea. And we've got a capacity in the complete North Sea over 150 gigawatt. So we've got a huge potential of renewable energy, for example, in the North Sea. And that's why we need hydrogen to make the wind energy, to convert it to hydrogen and to bring it into our energy system. The next thing is the role of ports in this whole picture is really important. So because in the future hydrogen will be an international market, and hydrogen will be transported from one country to the other country. And the role of ports, of harbors are really important to bring the hydrogen further, for example, into Europe. I mean, besides the technical drivers about renewable potential, there's also a lot of market drivers, infrastructure, which determine which country, or which area, of which continent even, will be, let's say, the first movers on the hydrogen part. And this graph says something about the potential. Different scenarios are given. And if we take the mid scenario, they're saying that in 2050, the potential capacity of electrolysis will be somewhere between 4,000 or 6,000 gigawatt in 2050. And imagine that I was just saying in the beginning, up to now, 100 megawatts installed. So the coming 30 years, you've got a great opportunity, a great challenge to work on. What's Europe doing now in the field of electrolysis? Hydrogen is now a key element in the European strategy and the European Green Deal. This summer, the Clean Hydrogen Alliance will become more concrete, and Netherlands and Germany is really leading this initiative. And I think it's great importance that industry, government, the transport operating companies working together, because it's not about production, it's about infrastructure, it's about storage, it's about the whole supply chain. And it's important that there is also from a government side, there is a scheme needs to be there to actually stimulate this development in that way that it's not too much pushing hydrogen, but make clean hydrogen available also compared to the alternatives. And one of the nice examples is an initiative for Hydrogen Europe to go to 2 times 40 gigawatt in 2030. One important thing is cross-border cooperation. These are 2 nice projects where Tina is working on. One is with Germany, where we're actually looking from can we use current gas infrastructure, can we use the storage capacity, can we connect the wind energy both in the Netherlands and Germany, produce hydrogen and transport it around Germany and to the Netherlands to the different industrial clusters. And this kind of cooperation between Netherlands and Germany and also between other countries is really important because one country can't do this alone. So that's a really important one. And the second one I want to talk about is about the hydrogen project, where we identified a lot of different technologies, energy carriers, hydrogen, but also energy carrier like ammonia, and how the future hydrogen market will look like, and what are the potential future new demands, what are the future costs, and how this market can be developed. And we identified 8-9 countries where hydrogen production can take place, and now bilateral discussions are going from can we maybe import hydrogen from, for example, Morocco towards the Netherlands. So a lot of initiatives are coming from there as well. Where are we standing now? Up to now, there are a lot of pre-feasibility studies, engineering studies, and first large-scale pilots. I just give here a couple. For example, we work on the North HU project, where the ambition is to go to 2-3 gigawatts before 2030. And it's a pre-feasibility study to see what's needed to actually make this possible. One of the challenges we see there, for example, is the supply chain. If you look at the electrolyzer stack, there are maybe now 2 or 3 parties delivering the membrane for the electrolyzer stack. So the complete supply chain is not developed yet. So in order to build really large gigawatt systems, we need the whole supply chain of the stack manufacturers, the components developed, and even the material supplies. The whole supply chain need to be developed, and that's one of the things we look from what's needed to actually make the 2-3 gigawatts possible within this decade. And all the other studies are looking at that as well. And the interesting thing is they're all connected to wind turbine, which is needed because it only makes sense to making green hydrogen connected to wind or solar, but also to look at alternative demands, for example, looking at aviation fuels or looking at the maritime sector. So these are feasibility studies. Also pilots are now on the way in the north of the Netherlands. A 20 megawatt initiative is signed this year. And in Austria already a 6 megawatt system is, electrolyzer system is running connected to a steel plant producing green hydrogen there. Designing a gigawatt electrolyzer plant is not that easy. I mean, up to now, there are projects done on a megawatt scale and there are containerized solutions. If we want to build a gigawatt electrolyzer plant, we need a complete redesign of the plant itself, let's say. And this this is a sketch for how such a design can look like. We've got here this design for an alkaline system. We've got here the different stacks standing. We've got a separate unit for the water demineralization. We've got a central compression. We've got obviously high voltage connection. And an optimal design is really crucial to get to the cost reduction, because a lot of the costs are actually in the electrolyzer stack, but a lot of it is also in the whole electrolyzer system and also the power connections. So an intelligent design is really important, and there's a lot of variations. Mainly thinking about maintenance, thinking about lifetime of these systems. That's where we're working on continuously. What's happening now in the Netherlands? I started with the international, I went to Europe, and now going into the Netherlands. Over 25 large projects are announced, and the projects differ. I mean, there are projects on the North Sea where we're building electrolyzer on an existing platform to see from how does an electrolyzer behave in sea conditions. We're looking at hydrogen storage from how does it work if we store hydrogen underground in an empty salt cavern? How can we learn from it, and what are the opportunities there? And obviously a lot of hydrogen projects connected to the large industry which are in the Netherlands. For example, connected to the steel industry, connecting to refineries, where green hydrogen is a good way to reduce the CO2 emissions. And this is not an extensive list, this is a complete list of all the projects which are being developed up to now. Important to say, I mean, there are a whole list of projects, but not many final decisions are made yet. So the coming years will be quite exciting to see how this will further develop. Now let's further look into the market. Looking to the market from the Netherlands and Germany. What do we expect that amount of hydrogen will we use in the future? Here you see four different scenarios, actually of three actually. One is the current demand in the Netherlands, our energy mix, and three demands in 2050, looking at the local, looking at the national, and looking at the international scenario. This is for the Netherlands. And you see that in this energy infrastructure outlook from the gas grid operator together with the transmission grid operator, they see hydrogen will get around 24% to up to 38% in our total energy mix. Electricity is obviously much more, 39%. But if we look at and the same for Germany, the numbers are a bit lower. But if we look from what will be the installed capacity in Netherlands or in Germany with electrolysis, and in red you see here the installed capacity, and there you see a big difference. I mean, in a local or national scenario where we really investing in the Netherlands and Germany in local renewable energy, so we're investing a lot in wind, a lot in solar, then there's definitely a need for hydrogen, because we need to convert some of that electricity into hydrogen and store it and transport it. I mean, in an international scenario, our local production will be much lower, and we will import a lot of that hydrogen. So the installed capacity in the Netherlands and even in Germany is much lower. And current policy will really are a combination of local and national. And import will get a role, but not as big as in this scenario is given. That's the current policy outline. How much hydrogen are we using now today in the Netherlands? Netherlands is, together with Germany, the largest hydrogen user and producer in Europe. And here you see some graphs from 2017 to 2019, where hydrogen is used in different industrial clusters. And important to say, this hydrogen are now used for example, for refinery or for fertilizer production. I mean, if you're looking 20 years further, you can question whether this industry will still exist and will stay in the Netherlands. But if we look at one other scenario, I just gave the scenario from an infrastructure perspective. As you know, we worked on two scenarios on how our energy system will look like in 2050. And these are complete other numbers. Here we see the different sectors: built environment, industry, transport, and see the hydrogen will be mainly used in the transport and in industry. And in the adapt scenario, we will do we we're not making major changes. And in the transform scenario, we're really changing our behavior and the way industry is now organized and the type of industry we have. And if we look now at the numbers, then hydrogen is 25.7 petajoules in both, about 50 gigawatts installed capacity in the Netherlands, much lower. And the difference between those scenarios, also interesting to see, is in this scenario, it's mainly low carbon hydrogen, so mainly using gas, SMR, ATR, and steam methane reforming, and capture the CO2 and store it on the ground in this scenario. And in this scenario, we're mainly working producing hydrogen based on electrolysis. So there's definitely a competition between those both. I mean, they can facilitate each other, but in this scenario, it's one or the other. But important to say, I mean, these are scenarios. I mean, we analyzed in the Netherlands more than 20 different scenarios. And on 2019, you see here the baseline demand based on the current industry. And there's a quite big range that the hydrogen demand in the Netherlands coming 30 years will or stay the same or will be like 5 or maybe a factor 10 larger. And the difference is really what will the transportation will do, what was the role of the industry. So main message I want to say here, I mean, hydrogen will play a key role, definitely electrolysis, because otherwise we can't integrate all the renewables into our energy system in the Netherlands and Europe or even worldwide. But the role of hydrogen in our complete energy system really is depending. Will be 5%, will be 20%, or even 30%. I'm already coming to the closure of this webinar. We organize the next webinar, and then we talk more about, we really go into that electrolyzer, and we talk about next generation electrolyzers. And this picture shows this is current generation electrolyzer where we're looking at now, and that's where we want to go towards gigawatt scale. But as Tino, we also develop the next generation electrolyzer, and what are the main challenges? And yeah, when will that next generation electrolyzer will be ready? Now, if you're interested, please join our next webinar. Thank you very much.
Thank you, Leonard van der Burg, for this interesting presentation on the Dutch experiences in green hydrogen production. Now, before we move on to the next and final speaker of the presentation session, I would like to kindly remind the audience to already type your questions in the Q&A session, so our translator has the opportunity to provide us with a translation before the start of the Q&A session. Then we now move on to the last speaker before the start of the Q&A session. The last speaker today is Wilco van Kampen, CEO of Syntec, who will give us an introduction on their smart alkaline systems.
Hello to all of you who are watching this video presentation today. My name is Wilco van Kampen and I'm the Chief Executive Officer of Syntec Global, a startup company based in the Netherlands. Today I have the pleasure of introducing Syntec Global and its electrolyzer system to you in a nutshell.
Climate change sets out the needs for reducing our carbon footprint. Hydrogen can make a significant contribution to clean energy transitions and minimizing greenhouse gases. But we all have a road to go in increasing the awareness and acceptance of hydrogen. Fortunately, there is a lot of energy and good vibes in terms of talking to all types of stakeholders about the application of hydrogen in our society. It is part of our daily routine to explain hydrogen technology and, in particular, electrolysis. Currently, hydrogen is enjoying unprecedented political and business momentum. It's now time to scale up technologies and bring down costs to allow hydrogen to become widely used. Before we zoom in on Syntec Global, let's put the Dutch ambition regarding the use of green hydrogen in perspective. The Dutch government has set a goal of installing 4,000 megawatts of green hydrogen capacity in the year 2013. That's only 10 years from now. But to put this in perspective, The 4000 megawatt is 20 times world's total manufacturing capacity of electrolyzers in the year 2019. So there's a long way to go. It is a massive ambition, even for a country of only 18 million inhabitants. Exentech is a startup company with all its amenities. That means small, adaptable, aggressive and exceptional technology driven. The venture was founded in 2012, and ever since all energy and activities are devoted to build smart alkaline electrolyzers for worldwide application. We work together with research institutes, universities and strategic business partners across a number of disciplines. It allows us to incorporate the latest business insights into our products. You can imagine that over the course of 10 years, a lot of knowledge and experiences were incremented. A brief glance at history shows that in 1766 it was the British physicist Henry Cavendish who discovered hydrogen as a gas. And only a few years later, in 1785, it was the Dutch scientist Martinus van Maeren who applied electricity in chemistry, and probably he was the first to use electrolysis. It was until the year 1826 that in the harbour of Rotterdam in the Netherlands the first gas factory was erected, and there they extracted hydrogen from coals. And in 1860, so only a few years later, there was a Belgian engineer, Mr. Lenoir, who developed a car fueled by hydrogen and carbon monoxide. He called it his Hippomobile. Isn't it remarkable that it took us 150 years before the idea dawned that hydrogen could play an interesting role in mobility? In the hydrogen value chain, we choose position as producer of smart alkaline electrolyzers. That is the area we operate in, and that position suits us best. We work strategically with manufacturers of compressors, hydrogen storage systems and dispensers, but we do not build these components ourselves. Our aim is to achieve harmony between making a profit, the environment, our customers and our employees. We want to excel and to become a front runner in our industry. It is well known that different market segments are subjected to different acceptance rates when it comes down to the use of hydrogen. Every market develops at its own pace, and it will take time before all markets reach maturity. Nevertheless, we see interesting possibilities in clustered applications, building a kind of local network infrastructure. We strongly believe that wherever initiatives arise, there is a future need for expandable capacity. The adage, one size fits all, does unfortunately not apply to electrolyzers. The question is, how can you expand installed capacity in a smooth, progressive way? Well, the answer is simple, by providing a product that is fit for purpose. The path we are pursuing towards a defined installed capacity is by applying the concept of economies of numbers instead of economies of scale. Our highly sophisticated and efficient gas modules, together with all other parts of the electrolyzer systems, are standardized and modular. And not to mention, they are equipped with embedded electronics. We strive for plug-and-play installation that can be extended at any given moment in the future. This implies that our system design is based on customer configuration instead of engineered solution. In our design, lifetime efficiency and reliable performance are key. Our electrolyzer systems are very suitable for dynamic use under varying load conditions. And without any hesitation or restraint, I can state that the aspect of safety is indisputable. High safety standards are paramount. It goes without saying that we meet all international technical standards. In regards to low environmental impact, I can say that we are in compliance with the Sustainable Development Goals, and for example do not use rare earth materials. With our electrolyzer system, we aim to serve the middle segments of the market. We call it the multi-purpose market, as explained a few slides back. For scalable projects ranging from 500 kilowatts up to 50 megawatt installed capacity, our system is unparalleled. We are very clear about our commercial strategy. It is centered on establishing 3 production facilities, one in Europe, one in Asia, and one in America.
I hope you enjoyed this presentation. We'd like to invite everyone who can or wants to contribute to our ambition, either technically, financially, or otherwise, to reach out to us. You are very much invited to a closer acquaintance, and as we all know, collaboration is a prerequisite for sustainable success. Thank you so much for watching this video.
Thank you very much, Wilco van Kampen. We have hereby come to the end of the presentation sessions. Before we move on to the Q&A session, I wish to thank all the speakers one more time for their great insights during the past hour. Also, I would like to remind everybody in the audience that next week at the same time will be the next episode of this 5-episode webinar series with the topic Application, Transportation and Heavy Industry. We are very much look forward to seeing you again next week as well. Thank you. Now, let us move on to the live Q&A session with the simultaneous translation. All right, thank you very much for your attention. We already received many questions in the Q&A, and we also already received several answers. Thank you very much for that. So what we'll do, we'll go through several of the questions that haven't been answered yet. And I also prepared some questions for our panelists that are interested, I hope, to all our speakers. The first question I would like to ask to our last speaker of today, which was Wilco van Kampen. Wilco van Kampen, because your company is a startup in the Netherlands in the hydrogen sector. And as we know also from Jörg Kickler's presentation, there are many companies already active in the Netherlands, startups and new companies. So I would like to ask you, from your experience, perhaps you could tell us something about the environment of Dutch startups in the hydrogen sector and something about the major threats and opportunities.
Thank you, Fons. Hopefully you can hear us at the moment.
Yes, clearly.
Well, is it easy, let's say, to be a startup in the Netherlands? That was your first question. I would say rather not, actually. It is quite difficult. To my opinion, the Dutch government has a great ambition, let's say, to support the green hydrogen transition or the energy transition towards green hydrogen. But that's policy. I mean, when it comes down to investment or funding, that's a different ballgame. And that makes it quite difficult in the Netherlands to be a startup. We do not have, in general, a climate of startup companies. It is more, let's say, interesting, let's say, to establish a company in the UK or America or somewhere else than in the Netherlands. So that's the answer to your first question. The threats, well, yeah, there are certain threats, certainly, yes. The thing is that we should speed up, and that makes it also challenging. Speed up means that all over the world we see a lot of opportunities, challenges for green hydrogen electrolysis projects. And so the question is, how can we reach out to them? And one of the things is to overcome the threats is cooperation, either nationally, so within the Netherlands, or outside of the Netherlands, for example, with partners in China. We certainly should, that's also what I mentioned in my presentation, we definitely should work together, we should collaborate, we should cooperate in every sense, let's say, to make this transition, this energy transition, a winning game.
All right, thank you very much, Wilco van Kampen, for your reply. If any of the panelists would like to comment on this, please feel free to raise your hand or just to unmute yourself. If not, I will go on to the next question. Okay, please, Jörg, I'll give the word to you.
Yes, thank you very much. What I would like to add to what Wilco said, that it is usually very difficult for new companies to enter an existing market. And what we see is that especially the large companies investing into hydrogen are not very keen to rely on new technology, but they'd rather invest in existing technology. So I fully understand what Wilco van Kampen says, that it is difficult for new companies to enter this existing, it's new, but it's also an existing market where large industries are sort of reluctant to invest into technology they don't know yet. So it's I understand this fully. That's what I would like to add. Thank you.
All right, thank you very much for the additional comment, Jörg Gigler. I would now like to, if there's no one who would like to comment on this, I would like to go to the next question, which was asked in the Q&A. And I thought this was a very good question, asked by Jimin Khan, who noticed that there are many different solar panels next to the highway from Beijing to Zhangjiakou, which is about 120 kilometers. So Jimmy's question is if these solar panels are being used for hydrogen production as well. So I think, Mr. Zhao, this question might be interesting for you to answer. All right, we're not sure. Mr. Zhao, maybe there's something with your microphone. Have a try, and then I'll come back with this question later. Thank you very much, and apologies to Jimin Khan for postponing the answer to your question. I would then like to go to the next question, question focused on for Leonard van der Burg, because as you know, actually TNO has many joint research projects, and we wanted to know if TNO currently also has some joint research projects with Chinese companies, perhaps in the field of hydrogen, and if not, in what kind of partners would the TNO be interested in from the Chinese side?
Thank you, Frans. Do you hear me right? Yeah. A really good question. Up to now, TNO have limited projects with China. I mean, we're doing a lot of projects, but it's mainly with European companies and companies from the US. So I think there are definitely opportunities to work on new research projects, and that can be both on joint technology development, demonstration. So yeah, I mean, there are definitely opportunities in the field of electrolysis. And for example, if you look at material development or component development, I mean, in the electrolyzer stacks, a lot of components already coming from China, and I think there are many improvements on material and component level in the electrolyzer stack. So I think there are definitely opportunities. So yeah, if there are companies interested, please contact me and see how we can work out, because it was mentioned already. I think we need all effort to really grow to a gigawatt scale. So yeah, no projects yet. We're getting requests. So yeah, let's see. Thanks.
All right. Thank you very much, Leonard. Would anyone like to comment on this? Perhaps Jörg Gigler, perhaps you can tell us something about Chinese hydrogen projects in the Netherlands, or perhaps you know something of projects, Chinese projects that are already active in your region?
There isn't much I can say about this, because I think that collaboration is a little bit limited. However, I know that there's a collaboration between the Dutch company Netstack and some Chinese companies who are producing fuel cell stacks for example trucks and buses, and I thought as well as range extenders for mobility. So yes, there is some collaboration, but I think that there is enough potential for much more intensive collaboration, not only between the Netherlands, but between Europe and China, because I think we both have very high ambitions as far as hydrogen is concerned. And I think this is a great opportunity to see how we can realize this together. Thank you.
Thank you very much, Jörg, for the additional comment. If Leonard doesn't have anything other thing to add, I would like to quickly reply to Mr. Jingmin's question that was raised to Mr. Zhao. So Mr. Zhao sent us a message via chat with the reply. And the reply is that solar panels are being used for production for the hydrogen factories in Zhangjiakou. Mr. Zhao, would you like to have a try and see if you can further elaborate via voice?
好的，我们这个张家口氢厂这个电力是来自于电网，但是这个电网本身这个在张家口这个可再生能源含这个比例是接近50%，是由这个张家口这个山上的这个风电场啊，还有光伏板来提供的。然后张家口这个可再生能源的这个比例以后会更高，能达到70%的这个比例啊。在张家口的项目呢，也有直接在风电场直接制氢的这个项目，但是由于他们那个地方呢，相对来说比较偏僻，地方来说运输也不太方便，因此呢，示范性比较大一些，主要是这个制氢的能力受到影响。以后随着这个改善，会被制氢厂、风电场直接制氢的这个案例会越来越多的。
Thank you very much, Mr. Zhao. I do have another question for Mr. Zhao, if you please don't mind. And that is because in terms of green hydrogen production, actually Zhangjiakou is ahead of other cities and other regions in China. And my question is, if you think that Zhangjiakou will keep this position in the future, and how open Zhangjiakou is for international projects settling in that region?
张家口非常欢迎国际合作进行氢能产业的发展。它已经跟那个国际上，比如大公司，比如这个 AP 公司，壳牌公司都有过接触，引进这些外国大企业在张家口进行大规模绿色氢气的生产，然后有可能还要生产这个大规模生产那个液氢，将这个产品液氢运往这个中国的大部分地区可以得到应用。
Thank you. And we did receive one question in the Q&A that's a following up question on the last one. And that is if there are already any Dutch hydrogen tech used in Zhangjiakou pilot project.
是我了解到，就是燃料电池跟荷兰的公司已经有过合作，而且是这个有一些项目正准备落地但是进展还是我了解一下，现在还不太清楚。
All right, that's okay. I understand. Thank you very much, Nancy Chen. And from the Q&A, I hope this answered your question. Thank you. Then because I think the UNDP is also very involved in this, and Mr. Zhang Weidong gave us the presentation, but unfortunately he couldn't be present today. So the Q&A part will be done by Wang Wanyi, who is working in Mr. Zhang's team. So perhaps I can ask a question to Wang Yi about maybe other regions in China that are just like Zhangjiakou, very active in hydrogen production, and perhaps which regions are very open to receive Dutch hydrogen projects.
Thank you very much for the question. Actually, UNDP is working with 7+1 demonstration cities in China, and these cities, if I would make a list, that would be Beijing, Shanghai, Foshan, Zhengzhou, Yancheng, Zhangjiakou, Changshu, and also Rugao. So all of these cities are very actively and also spearheading the hydrogen development in China, as well as fuel cell vehicles deployment. From what I know from these cities, that they're all very interested in international cooperation, also introducing internationally advanced suppliers and also companies to launch companies locally. So definitely there would be an interest, and cluster-wise in China, so the northern China part where Beijing, Zhangjiakou, and also Tianjin is located is one of the major clusters. And then the second one is the Yangtze River Delta. So that's where Shanghai, Rugao, and Changshu is located. And you can also look at the Greater Bay Area, which is Foshan and also Guangzhou. Many companies and research institutions are being very actively in that area. But there's also the Central China cluster where Wuhan is located. So really, if you look at the hydrogen development China, you see a very robust current situation. So if there's anything that UNDP could support, because we do have a very rich network locally since 2003. So we'll be happy to facilitate as well.
Right. Thank you, Mrs. Wang Wanyi. Then I'll move on to a question in the Q&A, a question from Pete Werner. And Pete asks, I understand that China has a large natural gas transportation grid already. Are there plans to convert this natural gas grid towards hydrogen transportation to also inject the large volumes of renewable energy, electricity, from outlying areas such as Inner Mongolia towards hydrogen to be transported to large cities and load centers? Mr. Zhao or Mrs. Wang Wanyi, I think either you would be interested in answering this question. Mr. Zhao, perhaps you could reply to this question. So if the current natural gas system, if there are plans to transport this to hydrogen transportation.
在中国有这个项目正在准备实施，技术上是已经不成问题，但是主要是考虑经济性，现在还要就进行这些经济核算的这些考虑，因为这个西北地区运送这个天然气管网里头要加轻牵扯到这个各种这个管道的这个安全性啊、密封啊、这个材料啊。才要进行一些个大量的认证，才能进行大规模的应用。所以中国做这个还是一些科研项目在做，还没有大规模的工业应用啊。这个但是以后会有应用的项目的。
I think Mr. Jörg Giggler would like to ask a follow-up question on this.
No, not a question, but I would like to add that also in the Netherlands and in Europe, we are working very intensively on the use of natural gas grids for hydrogen. We already have one project where a steel factory or a chemical factory is connected to a ammonia factory through a pipeline of about 10 kilometers. That was a natural gas pipeline, but it is now converted to hydrogen, so that the hydrogen is not only used for burning, so for high temperature heat production, but now the hydrogen is used for ammonia production. So we have some experience in that. And I know that also the International Gas Union is working on research to see if the natural gas grid can be used for hydrogen. And alongside that, I would like to mention that we have a big project in the Netherlands looking at ways of transforming part of our national gas infrastructure to hydrogen, to be used one way, so for hydrogen, but also to connect our neighboring countries, Germany, as well as Belgium, to that hydrogen network. So this is really an issue that's being investigated. And I think that's also, this is a topic that is very suitable for collaboration between China and let's say, the Netherlands or maybe even Europe to see what can we learn from each other in this field. Thank you.
Thank you, Jörg, for the addition and also for mentioning the Dutch project. I have some more questions about Dutch projects in a moment, but I would first like to give the word to Wan Yi, who seems to like to add something as well.
Thanks, Fons. Just to quickly add on to Mr. Zhao's point. So currently, well, some of the local governments do have plans for adding hydrogen into natural gas facilities. For example, there are already news and also plans from Jilin province, a city called Baicheng, and also Chengdu city in Sichuan province. And this is actually also a very important direction to look at for China. And so also want to emphasize that it would be great if we can facilitate a channel for China to learn from the Dutch experience of your current demonstration projects. Thanks.
Talking about demonstration projects, as you might well know by now, there are many projects already active in the Netherlands and also experiencing with new types of hydrogen production. And one of this is biomass. So using organic waste to create hydrogen. And I have a question about that for Jörg Giggler. Because Net Energy and the Vermeulen Group, they have a project in the Netherlands at the moment. And especially if this technology can be scaled up, almost definitely China will be very interested in this. So perhaps you can elaborate a little bit more about this project?
Yes, I'm not sure if I know what project you were referring to, but maybe I can first answer in general that I think that the production of hydrogen from biomass is not the preferred route for, let's say, the Netherlands or maybe even for Europe. One of the main factors being that the availability of biomass is limited. So what I see, but I must stress that I do not have a crystal ball so I can predict the future, but what I expect, what I expect that could happen is that we use biomethane to replace natural gas, for example, in the built environment and in mobility, and that we will not use green gases, biomethane, for the production of hydrogen, because I think that the whole production chain will become too expensive unless you have a technology that is available to convert biomass directly into hydrogen without the intermediate step of producing biomethane. And a good example of that is supercritical water gasification. That produces in a sort of a steam cooker, sort of a rice cooker actually, under high pressure and high temperature. It converts biomass into hydrogen and CO2. So that could be interesting, but in my opinion, I think that due to the limited availability of biomass, at least in the Netherlands, that it is not a preferred option.
Thank you very much, Mr. Jörg Giggler. I would like to ask a similar question to Mr. Zhao about his opinion of using biomass to create green hydrogen.
生物智能智星在中国，还有一些个小型的示范，但还没有大规模应用。主要是还是考虑经济的这个就是出口的这个用途，还有它的价格。因为目前这样的方法呢，价格比较高，在市场上呢，没有竞争力，所以呢，这个还没有大规模应用。
Right. Thank you, Mr. Zhao. Mrs. Wang Wanyi, is there anything you would like to add on to it? Otherwise, I will go on to the next question.
Perhaps not much from my end. Thanks.
All right, no problem. The next question is a question from the Q&A that our local translator and my colleague Karen helped to translate. And she, the question in the Q&A, the English version is, what is the electricity price used for Zhangjiakou project? Normal industrial electricity price or other type of electricity prices?
张家口采用了一个叫四方机制的这个优惠电价来鼓励企业退氢。这个四方机制呢，是由这个看看四方机制就由当地政府、电网、电企业还有用户四方协作，协调这个搞一个电价，是一个优惠电价，比工业上网就比工业电价能够优惠很多，这样才能够给企业做退氢才能带来可能的利润，所以这是一个优惠电价是可以做到的。
And there was another question for Mr. Zhao in the Q&A, question from Art, and he's asking how you can guarantee that the green electricity is being used as a source for hydrogen and not the fuel, fossil fuels, for example, coal plants, especially in that region in China, there are still many coal plants. What's Mr. Zhao's opinion on that?
在张家口做制氢是两种方法，一种是在这个风电场直接从这风电这个发电直接用制氢的，这是一般的规模比较小，这些个目前来说还是示范为主啊。大规模制氢一般还是通过电网到这个化工园区的制氢厂进行制氢，但是因为张家口地区本身那个可再生能源在这个电力网里的比例就高，能达到50%，以后还能达到70%。因此，我们就认为这是通过这个绿色可再生能源通过电网输送到制氢企业呢，也是一种绿氢的一个应用的方式。
All right, thank you very much. We're nearing the end of the Q&A session, so we still have about 5 minutes remaining according to our schedule. There are less and less questions in the Q&A. So if there are no more questions, 1 second, I see we just received another question from Jing Min. He's asking, because he knows, he mentions, that there are technologies in the Netherlands converting hydrogen into biomethane with quite a high efficiency. Are these applications also interesting for the Chinese market, for instance, in Zhangjiakou?
我们希望这个荷兰企业把相关技术跟我们做交流，然后我们把这个项目推荐给相关的企业进行下一步的合作，争取把它落地在张家口。
Okay, I think many of the Dutch parties are interested in hearing that. Looking ahead of next week's webinar, which will be about applications, heavy industry and transportation, I have one final question I would like to ask to Jörg Gigler, because he knows many active projects in the Netherlands. I would like to ask him from his position if he thinks the Netherlands, which is currently quite strong and innovative in many different hydrogen applications, why is this, from Jörg's personal opinion?
Thank you for this question. The reason why I think there is so much focus in the Netherlands on hydrogen is twofold. The first of all is that we have quite a large chemical industry, as well as mobility and the built environment, that are looking for carbon neutral solutions. So if we look at the challenge of mitigating climate change, hydrogen is a perfect solution. On the other hand, we have quite a large potential of offshore wind on the North Sea. And that potential can and should be explored. And we have an opportunity not only to use the electricity directly that's produced there, but also because through electrolysis, we have a means of sector coupling, of system integration, of storage, of seasonal storage, by converting that electricity into hydrogen. And maybe a third reason, let me add that too, is we are a natural gas country. So we have explored and produced natural gas since early 1960s. And because we are a natural gas country, we have a lot of natural gas knowledge, and we have a lot of natural gas assets. And hydrogen is a good way of still using that knowledge and using those assets. So we sort of have a head start by using what we built up in the past 60 years with natural gas. So I think that's for society a very interesting and cost-effective solution. Thank you.
Thank you very much, Jörg. I think this question will be a very good introduction also to the next webinar, which will be about application. But there is one final question, and I noticed that he was also one of the first to ask from Xu Junhui, and he's asking about salt caves, if salt caves can be used for hydrogen storage, and if there are already some applications in this field.
I'm not sure whom you would like to ask this question to. Maybe this is a good one for Lennart to answer.
Yeah, I can answer. Oh. Thanks, Jörg. Yeah, I can answer. In the Netherlands, we're doing now an experiment in ISOC where we look at empty salt caverns to actually store hydrogen underground, and also looking at empty gas field. But actually, salt caverns are really have a lot of potential in the Netherlands, but also in Germany. So yeah, that's definitely a solution, and that's actually needed because we need cheap solution for high pressure hydrogen storage, and then we need make use of the underground. So we're starting actually an experiment, and also examples, for example, in Argentina, where they also did it on a larger scale. So yeah, there are pilots done, but we definitely need to work on that further. I don't know if that answered the question well enough, but maybe offline, if there are more detailed questions, we can discuss that. Thanks.
All right, thank you very much, Lennart van der Burg. If I'm not mistaken, that answers all the questions. And we've also reached our time, which is 5:45 Chinese time or 11:45 Dutch time. So we've saved all the questions that were asked during the chat, and any unanswered questions, we'll make sure that we'll upload them on our website, just as our video, so everyone can rewatch the presentation session as well as the Q&A session. So I would like to thank all the panelists very much for their time and for the presentations, and also the audience for your attention and the very good questions asked. So please remember, next week, same time, there will be the third episode of our webinar series, and we'll look more into details of hydrogen applications, industry, and transportation specifically. Thank you. See you next week.